Welcome everyone to another wonderful session of Amazing World of Science. And as many students had asked me to do surface chemistry for class 12 NCERT line to line, we'll just do a quick revision of surface chemistry, which is an important chapter where you get many questions from for your entrance exams. So just we'll start with the unit 5 surface chemistry class 12 NCERT. So first of all, what is meant by surface chemistry? So surface chemistry, it is nothing. It deals with the phenomena that occur at the surfaces or interfaces. So surface chemistry is nothing but it occurs at only the surface or the interface. So interface or surface both are represented. Interface is also known as surface. It is shown by the separating the bulk phases by a hyphen or slash. Either you put a slash like this or a hyphen like this, which shows the separation of the phases. Like interface between a solid and a gas can be shown like see solid hyphen gas, or it can also be written as solid slash gas. So, due to complete miscibility, there is no interface between gases. See, gases will fully mix up entirely. So, there is no surface or interface between separation between gases because the entire thing is mixed together. And the bulk phases that we come across in surface chemistry can be pure compounds or solutions. So, we can either consider pure compounds or solutions, which are the bulk phases we see in everyday life. So what is interface? It is nothing but a few molecules thick, and its areas, it depends on the size of the particles of bulk phase. So a little bit of thick layers of molecules is known as interface. And what is the area factor depends on only the size of the particles which forms the phases. So many important phenomena like noticeable for this phenomena is corrosion, electrode processes, heterogeneous catalysis, dissolution, crystallization. These all occur at the surface or the interface. And what is the importance of the topic surface chemistry? So much of applications is there in industry, analytical work and daily life situations. So how do you accomplish the study of surface chemistry? It's so important. See, to have a really clean surface under very high vacuum, that is of the order of 10 raised to minus 8 to 10 raised to minus 9 Pascal. Now it is easy to obtain ultra clean surface of the metals. You can just vacuum it, and solid materials with such clean surfaces need to be stored in vacuum always, otherwise they will be covered by molecules of the major components of air, namely dioxygen and nitrogen. So unless you store these metals in clean places, like unless they are stored in vacuum, they will get a coating by the molecules of air like dioxygen and dinitrogen N2 and O2. So here in this unit, what you are going to study is important features of surface chemistry like adsorption. You might be hearing this word for the first time. It's not absorption. These two are adsorption is different from absorption. And catalysis. Okay, so catalysis and colloids, including emulsions and gels. So all these things you are going to learn in this unit. That is adsorption, catalysis, colloids, including emulsions and gels are all colloids. Okay, now we will see like what is meant by adsorption. Okay, adsorption means several examples you can see for adsorption. That is the surface of a solid has a tendency, it can attract and retain molecules of the phase with which it comes into contact. Suppose solid comes into contact with the surface, then that solid can keep the molecules of the phase with itself. It can attract and keep it. So the molecules remain only at the surface and it won't go deep inside. Okay, it remains only at the surface. So the molecular species or that is the accumulation of molecular species at the surface rather than in the bulk of a solid or liquid is known as adsorption. Now you follow what is meant by adsorption. Clear, children? Like it is a phenomena where the molecular species will accumulate only at the surface. It won't go deep inside. Okay, so that process is called adsorption. The molecular species which concentrates or it gathers at the top of the surface, we call it adsorbate, and the material on the surface of which this process takes place is what is called as adsorbent. Now you come across some new terms, what is meant by adsorption, adsorbate and adsorbent. So as we again repeatedly say, adsorption is only a surface phenomena. It is solid, particularly in finely divided state, they are having larger surface area. So like charcoal, silica gel, alumina gel, clay, colloids, these in finely divided state they will act as good adsorbents. Okay, because it's a surface phenomena, and if you divide the particles into finely divided state, then they can act as good adsorbent. Then adsorbents in action, like a gas. See, take the cases of gases like oxygen, hydrogen, carbon monoxide, chlorine, NH3, ammonia, sulfur dioxide. Suppose if you take them in a closed vessel and if you keep some powdered charcoal inside them, we have seen some particular phenomena that the pressure of the gas in the enclosed vessel will decrease. So if you keep these gases inside a vessel having powdered charcoal, then the pressure of the gas in the vessel will decrease. So why does this happen? The gas molecules concentrate at the surface of the charcoal. So all the gas molecules will move on to the surface of the charcoal, but inside nothing is there. So that means we can say that the gases are adsorbed at the surface. Then another case, that in a solution of an organic dye like methylene blue, see that is an organic dye. So you add animal charcoal to it and then shake the solution well. Then you can see that the filtrate changes to colorless. So the molecules of the dye, what happens, they will accumulate at the surface and we can say that they are adsorbed. Okay. Then another example, aqueous raw sugar solution. If you pass it through beds of animal charcoal, again it becomes colorless because the coloring surfaces are adsorbed by the charcoal. Then air becomes dry in the presence of silica gel because the molecule gets adsorbed on the surface of the gel. See, now within now you could have had a fair idea of what is meant by adsorption. So it's clear from all these examples that solid surfaces can hold the gas or liquid molecules by adsorption. So the process of removing an adsorbed substance from a surface where it is adsorbed, we call it desorption. Opposite of adsorption, removal of the molecules from the adsorbed surface, we call it desorption. Okay, in adsorption the substance is concentrated only at the surface and it does not go into or penetrate through the surface to the bulk of the adsorbent. But while in absorption, substance is uniformly distributed throughout the bulk. Okay, not alone on the surface but throughout the bulk phases, it gets bulk of the solid, it gets distributed. Suppose when a chalk stick is dipped into the surface, it retains the color of the ink. If you dip it in ink due to adsorption of color molecules, so what happens is that the solvent of the ink goes deeper into the stick due to adsorption. Okay, now what happens, just try to break the chalk stick. You can see that it is white from inside it is white, so only on the surface you can see the blue color. So how can you distinguish between absorption and adsorption? Just take the example of water vapor. So water vapors are absorbed by anhydrous calcium chloride, absorbed by anhydrous calcium chloride but adsorbed by silica gel. So adsorption, concentration of the adsorbate increases only at the surface of the adsorbent, while in absorption it is uniform throughout. That's a simple thing. You are getting an explanation with various examples. Now both these processes, adsorption and absorption, can take place simultaneously, and you can use the term sorption to describe both the process. So this is a little bit important chapter. So next session I will teach you about the mechanism of adsorption and different types of adsorption. Okay, you learn little by little. Otherwise, if you try to learn everything together in one class, you will find it. I have seen many sessions for around 1 hour or 1.5 hours teaching the whole lesson. But if you focus entirely, now it is difficult for you to learn. That is why many students are telling me to upload the lesson in simple, split it into simple parts and upload it. So with this, we will learn the next topics in the next session. So parallelly I'm also doing 11th chemistry as well as class 9 and 10. So since I am having a very hectic schedule, whenever I get time, so in between I will surely keep on uploading these chapters for me, for all of you, and also do like, share and subscribe our channel Amazing World of Science, and also share it with your friends, and just don't visit the classes and go without subscribing to our channel, and don't forget to press the bell icon as well, so that you will get the notifications immediately. So that's all for today. Thanks for watching.